Okay, hello, this is Dr. Hanaa Assil, and this is paper 2CR of January 2020 in the IGCSE chemistry Edexcel. So let's discuss these questions. The first one says substances can be classified as elements, mixtures, or compounds. Each box represents an element, a mixture, or a compound. Which box represents a mixture? I'm going to remind you again, a mixture is two or more substances added together. So you have to have different types of balls or symbols in a certain box. So of course, the one that represents a mixture is the one in box 2. You have two different types of substances. Okay, which two boxes represent elements? Remember that elements means all the atoms are the same. So you're going to choose a box in which all the atoms are identical. So of course, box 1 is an element, and box 3 also is an element because all the atoms are the same. Explain why box 5 represents a compound. So it is a compound because it is made up of different elements chemically combined together. Okay. The periodic table contains all the known elements. How are the elements arranged in the periodic table? So how do we arrange the elements in the periodic table? You should know hydrogen, helium, lithium, beryllium, boron, and so on are arranged according to increasing proton number of protons or atomic number. That is what we arrange the elements according to. Elements in the same group have the same number of what? So if something is in the same group, everything in group 1 will have 1 electron in outer shell. So all the elements in the same group have the same number of electrons in outer shell. This question is about chromatography. A student does a chromatography experiment to analyze the composition of green food coloring in sweets. She places 4 known dyes and the green food coloring on chromatography paper. The question is, the diagram shows that the student makes 2 mistakes when setting up her apparatus. State the 2 changes that the student should make to her experiment so that her experiment works. Well, looking at the diagram, obviously she has done a mistake in what? The start line, he says the start line is drawn in ink. Well, it shouldn't be drawn in ink, it should be drawn in pencil. The level of the water or the level of the solvent is above the start line. That is wrong. It should not be above the start line. It should be below the start. Another student does the chromatography experiment correctly. The diagram shows her chromatogram at the end of the experiment. Explain what the chromatogram shows about the composition of the green food coloring. Where is the green food coloring? That's the last one on the right. Okay, so from this chromatogram, what can we tell about the green food coloring? Well, obviously, we can say that it is made up of 3 components because it gives 3 spots. One of the spot is the same level as B. The other spot is the same level as D, so that means it contains B and D. It has a third spot that is not similar to A or B or C, so it is an unknown substance. And obviously it does not contain A or C. It doesn't have a spot the same height as A or C. Then he says the distance between the start line and the spot for dye C is 6.2 centimeters. Calculate the RF value of C. Now, first of all, how do we calculate RF value? You should know that RF value is the distance traveled by the spot over the distance traveled by the solvent. He already tells me that the distance traveled by the spot is 6.2. So what we do is we measure with a ruler the distance traveled by the solvent. That means the distance from the start line, where the spots were originally placed, to the solvent front. So that if it's measured in the question paper, it's 9.5. So that means that my RF value is 0.65. Then he says, suggest why dye A does not move. Of course, we said in chromatography, if a substance remains on the start line, that means it is insoluble in the solvent or insoluble in water in this case. Solutions of silver nitrate and potassium chloride react together to make the insoluble salt silver chloride. A student uses this method to prepare a sample of silver chloride. Add 25 centimeter cubed of silver nitrate to a conical flask, add potassium chloride to the flask, and then filter off the silver chloride. So obviously he's preparing the insoluble salt silver chloride by the method we called precipitation. So what term is used for this reaction? When we form a precipitate, this is called precipitation. Give two more steps that will produce a pure dry sample of silver chloride. He already said that he added them together. What should he do after that? Wash the residue, filter. He already filtered. So wash the residue with a few drops of distilled water and dry between filter papers. Acidified silver nitrate solution is used to test for chloride ions. Give a reason why hydrochloric acid is not used. Of course, remember that the test for chloride ions was what? Add dilute nitric acid and silver nitrate. I cannot say add dilute hydrochloric acid and silver nitrate because the hydrochloric acid originally contains chloride ions. If I use it, it will give a white precipitate with the silver nitrate, regardless of what the original substance that I am testing contains. Then the chemical equation for the reaction between solutions of silver nitrate and potassium chloride is this. A student adds an excess of potassium chloride solution to 25 centimeter cubed of 0.1 mole per decimeter cubed silver nitrate solution. Calculate the maximum mass of silver chloride that can be produced. That means calculate the mass of silver chloride that we should get from this reaction. So again, what's the first thing we should do? He gives me information about what? About silver nitrate, 25 centimeter cube, 0.1 mole per decimeter cube of silver nitrate. So the first thing that I need to do is get the number of moles of silver nitrate. I have concentration and volume, so the number of moles of silver nitrate is concentration times volume. Remember that the volume that he gives me, I have to divide by 1,000. So this gives me the number of moles of silver nitrate. Then the next step is I look at the equation and I compare the moles of silver nitrate to the number of moles of what he's asking about. What is he asking about? He's asking about silver chloride. Well, obviously from the equation, the number of moles of silver chloride is the same as the number of moles of silver nitrate. Now he wants mass of silver chloride. Mass is number of moles times mR. So multiply by the mR of silver chloride, and that gives me a mass of 0.36 grams. This question is about the metal lead. Explain why metals such as lead are malleable. So in general, why are metals malleable? Remember that this is because the layers of positive ions can slide over each other easily when heated or hammered. Remember. A teacher uses this apparatus in a fume cupboard to demonstrate the electrolysis of lead bromide. The lead bromide is heated until it melts. When the lead bromide melts, the lamp lights. One of the products of this electrolysis is lead. State why solid lead bromide does not conduct electricity. What is lead bromide? You should know that lead bromide is an ionic compound. And we said solid ionic compounds do not conduct electricity because when they're solid, the ions are not free to move. Remember that an ionic compound is made up of positive and negative ions. As a solid, the ions are not free to move. Bromine is formed by oxidation of bromide ions at the positive electrode. Of course, oxidation means loss of electrons. So you should realize that the bromide ions become bromine and they lose 2 electrons. Explain why lead metal forms at the negative. Of course, the lead, when we do electrolysis of molten lead bromide, the lead is a positive ion. Now, it goes to which one? It goes to the negative electrode. So the lead ions are positively charged. They are attracted to the negative electrode. And remember, the positive goes to the negative to gain electrons. And it becomes the lead atoms. The teacher stops heating the mixture, allows it to solidify. So just why the lamp stays alight. Remember, what do we have? We did electrolysis of lead bromide that formed lead metal. Now, if I leave it to solidify, then all of the substance in the crucible is now lead metal. And of course, metals conduct electricity. So lead is formed from the electrolysis, and this is a metal that conducts electricity. This question is about group 1 metals. When lithium is added to water, bubbles of hydrogen gas are observed. Give 2 other observations. So he already tells you that when I put lithium in water, it gives bubbles of hydrogen gas. Now, 2 other observations. Please don't say fizzing. Fizzing is the same as bubbles. He already mentioned bubbles. So what other observations do we see when we put lithium? Remember, lithium is in group 1, as he said. Do not mention bubbles of hydrogen. I need to mention something else. You should realize that the ones in group 1 float on the water. They dart or move around on the surface of the water. And then as it reacts, the solid will disappear. Give the test for hydrogen gas. What was the test for hydrogen gas? Insert a lighted splint, it pops. Give one observation that would be different if potassium is used instead of lithium. So we said when I put lithium, it gives bubbles of gas, it floats, solid disappears. What is different if I put potassium? Remember that potassium is at the bottom or lower than lithium in group 1, so it is more reactive. So if I put a piece of potassium in water, you will see that it has more vigorous fizzing or more violent fizzing. You can also mention the fact that it will catch fire. It actually forms a lilac flame. So it will catch fire. Remember, when we talk about lithium, lithium will not catch fire. Sodium may catch fire. Potassium will certainly catch fire. Then he has the diagram represents an atom of lithium and an atom of potassium. Explain why potassium is more reactive than lithium. Remember, as we go down group 1, the metal becomes more reactive, and you should be able to explain that. This is because potassium has the outer electron further away from the nucleus. It has more shells, bigger atom. So the outer electron is further away from the nucleus. That means less attraction force between the nucleus and the outer electron. So the electron is more easily lost. Remember, a metal needs to lose electrons. If it can lose it more easily, then it is more reactive. The equation for the reaction between lithium and water is this. A mass of 0.5 grams of lithium reacts with an excess of water. Calculate the volume of hydrogen gas. So how do we calculate the volume of hydrogen gas? The first thing we do is number of moles of what he gives me. So he gives me information about lithium. I get number of moles of lithium. Now what does he give me? He gives me the mass. Then I use mass over molecular mass of lithium and get the number of moles of lithium. Then he's asking about what? About hydrogen. I look at the equation. And I find that the equation says if I have 2 moles of lithium, they will give 1 mole of hydrogen. That means number of moles of hydrogen is half the number of moles of lithium. And then I can get volume of a gas. How do we get volume of a gas? Volume of a gas is number of moles times 24. He wants it in centimeter cubed, so I need to multiply that by 1,000. Okay. Then there is something else. We haven't finished. The question says, give your answer to 3 significant figures. Can you see that? Please pay attention to all the calculation questions Note whether he's telling you a specific number of significant figures or a specific number of decimal places. That means that my final answer has to be 857 centimeter cubed. In a reaction between lithium and water, 150 centimeter cubed of lithium hydroxide is formed. The lithium hydroxide solution is then completely neutralized by 24.85 centimeter cubed of 0.1 mole per decimeter cubed sulfuric acid, and he gives me the equation. Now, what does he want? Calculate the concentration of lithium hydroxide. Again, what do we have information about? We have 24.85 centimeter cubed of 0.1 mole per decimeter cubed of sulfuric acid. So he gives me information about sulfuric acid. I get the number of moles of sulfuric acid. Concentration times volume. Do not forget to divide the volume by 1,000. This gives me number of moles of acid. Next step, what is he asking about? Lithium hydroxide. I look at the equation. Compare the number of moles. As you can see, the equation says 2 of lithium hydroxide reacts with 1 of sulfuric acid. So that means that number of moles of lithium hydroxide will be twice what we have. Then he's asking for what? Concentration. Concentration is number of moles over volume. Again, the volume of lithium hydroxide is 150. I divide by 1,000 before I put it into the equation. Are we following? Okay. This question is about ethane and ethene. Ethane is obtained from crude oil. Describe the industrial process used to separate crude oil into fractions. So how do we separate the different fractions in the crude oil? Remember, the crude oil is heated and vaporized. Then it is cooled and condensed in the fractionating tower or the fractionating column to give different fractions at different boiling points. You have to indicate that the fractionating column has a gradient of boiling points. The one with the lower boiling point is collected at the top. The equation for the reaction between ethene and hydrogen is this. The rate of this reaction can be increased by increasing the pressure. Explain why increasing the pressure increases the rate. Increasing the pressure means bringing the particles nearer to each other, and that means particles are closer to each other, so more collisions occur per minute, or there are more frequent collisions. The rate of this reaction can also be increased by using a catalyst. Explain how using a catalyst increases the rate. Remember, if we use a catalyst for any reaction, what happens? It provides an alternative pathway for the reaction which lowers the activation energy. Remember, the activation energy is the distance from the reactant, or the difference in energy from the reactants to the top. So when we use a catalyst, then the energy of activation is much lower. This makes the reaction faster. Give one other way that the rate of reaction between the gases can be increased. What did he mention? He mentioned increase in pressure, and he mentioned using a catalyst. So another way would be to increase the temperature. Reaction between ethene and hydrogen is exothermic. Complete the reaction profile diagram. Again, we said reaction profile diagram means you show where is the activation energy, where is the enthalpy change. Exothermic means the products are where? We said exothermic means the reactants lose energy, and that means that the products will have lower energy. So the products are lower than the reactants because it's exothermic. Now, where is the activation energy? It is the difference in energy from the reactants to the top. Where is the delta H? From reactants to products. Then we have this bond energies and this reaction, and he says use the bond energies to calculate delta H. Again, how do we use bond energies to calculate delta H? We said we determine the amount of energy needed to break the bonds in the reactants, amount of energy needed or released when bonds are formed in the products, and then we say reactants minus products. So before the arrow, I have 4 CH bonds. Each of them need 412. plus I have one C double bond C that needs 612, and I have one HH that needs 436. So this is the total amount of energy needed to break the bonds in reactants. Now, where are the products? After the arrow, I have 6 CH bonds. So, and I have one C single bond C. To get the delta H, I subtract the reactants minus products. So that comes out to be minus 124 kilojoule per mole. Ethanol can be produced by fermentation of glucose. Complete the equation for fermentation of glucose. Remember, fermentation of glucose is when we put yeast on glucose. It will give ethanol plus what? Remember, it gives ethanol plus carbon dioxide. State why it is necessary for fermentation to be done in the absence of air. We don't want oxygen. Because if there is oxygen, then the ethanol that is formed will be oxidized to ethanoic acid. So instead of getting ethanol, we get ethanoic acid. And this is not what we want. Explain why the temperature should not be higher than 40. Remember, we said we added yeast to the glucose. The yeast has enzymes. We don't want to denature the enzymes in the yeast. So we use temperatures lower than 40, we use it at 30 degrees or 35 degrees to avoid denaturing the enzymes in the yeast. Then he says, when 4 mole of glucose is fermented, a mass of this of ethanol is produced. Show that the percentage yield is 15%. Okay, please do not confuse the 55.2 grams of ethanol as the mass of ethanol that is obtained. This is the mass of ethanol that he obtained when he did the reaction. But in order to get the percent yield, I have to calculate what is the mass that he should have obtained. So if I start with 4 mole of glucose, what would be the number of moles of ethanol that I should get? Well, obviously from the equation, it's twice. So that means I will get 8 moles of ethanol. Now, what is the mass of that? Number of moles times mR. So I should get 368 grams. But what did he actually get? He got 55.2. So the percent yield is what he actually got over what he should get from our calculation times 100. So that comes out to be 15%. Ethanol can also be produced by reaction between ethene and steam. This reaction is in dynamic equilibrium. Give 2 features of a reaction dynamic equilibrium. Again, when a reversible reaction reaches dynamic equilibrium, what is happening? Rate of forward reaction equals rate of backward reaction, and concentration of reactants and products remain constant. Please do not mix up any of these. This is the 2 requirements for dynamic equilibrium. Rate, don't say forward equals backward. Rate of forward reaction equals rate of backward reaction, and concentration of reactants and products remain constant, not equal. They remain constant, so they remain the same, but they're not equal to each other. Okay? When the equilibrium mixture is heated, the yield of ethanol decreases. Explain whether the forward reaction is exothermic or endothermic. Remember, we said he's trying to heat up the reaction. And we said if we increase the temperature, the reaction will go to which side? Increasing the temperature, the reaction goes to the endothermic side. So he's saying that the yield of ethanol decreases, and that means that when he increased the temperature, the reaction went backward. Backward will cause the ethanol to decrease, and that means that the forward is exothermic. Okay, so forward reaction is exothermic. This is because increase in temperature causes the reaction to shift to the endothermic side. In this case, it went backward and formed less ethanol, and that means that the forward is exothermic. Carboxylic acids react with alcohols to form esters, and he gives me the structure of an ester, and he says draw the carboxylic acid and alcohol that react to produce this ester. In this ester, which part was the acid, which part was the alcohol? Remember, the one that has the C double bond O, that's the one that was the acid. So I draw it as an acid with a double bond O, single bond OH. Now the other part here, that was the part that was the alcohol. The part after the C double bond O, that's the part that was the alcohol. So which alcohol is this? Obviously this is the alcohol that has the 4 carbons, and then you add OH. Remember that you cannot put the H in the middle. It has to be O attached to the carbon, and then the H is on one end. Indicators can be used to test for carboxylic acids. Describe a different chemical test for a carboxylic acid. So he doesn't want to use indicators. What was the other test for carboxylic acids that we said we could use? Remember that we said we use acids to test for what? We use acids to test for carbonate, so we can use carbonate to test for acid. So if I add this liquid that I want to show is an acid, if I added sodium carbonate and it gives bubbles of gas that turn lime water milky, that means that liquid is an acid. And that's the end of this paper. I hope this was useful to you. Thank you for listening.